Good evening, Sir Michael Pagustan. I am Angelo Miguel Abalos. I am about to report is about induction system of gas turbine engine. A gas turbine engine consumes considerable more airflow than a reciprocating engine. The air entrance passage is correspondingly larger. Furthermore, it is more critical in determining engine and aircraft performance, especially at high airspeeds. Efficiency of the air inlet duct result in successively magnified losses through other components of the engine. The inlet varies according to the type of the gas turbine engine. Small turboprop and turboshaft engine have a lower airflow than a large turbofan engines, which require a completely different types of inlet. Many turboprop auxiliary power units and turboshaft engine use screens cover to inlet to prevent foreign object damage. As, as aircraft speed increases, thrust tends to decrease somewhat as the aircraft speed reaches a certain point. Ram recovery compensates for the losses caused by the increase in speed. The inlet must be able to cover as much of the total pressure of free airstream as possible. As air molecules are trapped and begin to compress the inlet, much of pressure loss is covered. This added pressure at the inlet of the engine increases the pressure and airflow to the engine. This is known as ram recovery or total pressure recovery. The inlet duct must uniformly deliver air to compressor inlet with as little turbulence and pressure variation as possible. The engine inlet duct must hold to drag effect on the aircraft to the minimum. Air pressure drop engine is caused by the friction of the air along both sides of the duct and by the blend in the duct system. Smooth flow depends upon keeping the amount of turbulence to a minimum as the air enters the duct. On engines with flow rates turning, the airflow allows the engine to be a smaller, have less drag. On turbofan engines, the duct must have sufficiently straight section to ensure smooth, even airflow because of the high airflows. The choice of configuration of the entrance to the duct is dictated by the location of the engine within the aircraft and the airspeed, altitude, and attitude at which the aircraft is designed to operate. Divided entrance duct. The requirements of high-speed single or twin-engine military aircraft in which as the pilot sits low in the fuselage and close to the nose render it difficult to employ the older types of single entrance duct, which is not used on the modern aircraft. Some form of the divided duct which takes air from either side of the fuselage has become fairly widely used. This divided duct can be either a wing root inlet or scoop at each side of the fuselage. Either type of the duct presents more problems to the aircraft designer than a single entrance duct because of the difficulty of obtaining sufficient air scoop area without imposing prohibitive amounts of drag. Internally, the problem is the same as the duct encountered with a single entrance duct. To construct a duct of reasonable length as a few bends as possible. Scoops at the sides of a fuselage are often to use. These scoops are placed as forward as possible permit a gradual blend toward the compressor inlet making the airflow characteristics approach those of the single entrance duct. A series of turning turning vanes in something placed to aside the scoop inlet to assist the straightening of the incoming airflow to prevent turbulence. The main function of the inlet duct is to furnish the proper amount of air in the engine inlet. In a typical military aircraft, using a turbojet or low bypass turbofan engine, the maximum airflow requires are such that the Mach number of the airflow directed to ahead of the engine in less than Mach 1 airflow through the engine must less than Mach 1 at all times. Therefore, under all flight conditions, velocity of the airflow as it enters air inlet duct be reduced through the before it's ready to compressor. The accomplishments of inlet duct designed to function as a diffuser, decreasing the velocity and increasing static pressure of the air passing through them. As with military supersonic aircraft, a diffuser progressively decreases in area in the downstretch of direction. Therefore, a supersonic inlet duct follows this general configuration